Okay, welcome back. And today we're going to do the end of Lecture 5 and the start of Lecture 6. And I believe that I stopped talking about SAP, or right before SAP, which is around slide number 41. So let me quickly go to that. Let's see my slide numbers on here. Do I have the right lecture? I think I do. Yep. This lecture, number 5, is all about CRM, ERP, customer service relationships, supply chain, putting pieces together, the origins of a lot of different types of systems, e-business, outsourcing. We talked about supply chain management, and I think this is where we kind of stopped, I believe, right around, I think we talked about customer relationship management, Salesforce, if any of this looks familiar. The concept of data mining, did we talk about that? I think we did. Business intelligence. Let's see, hold on a second. The slide's going to go a little slow for us. There we go. I remember this. Talked about we talked about data mining, and I gave you some examples. Some of this, I think this is where we stopped. I mean, some of the areas I hit a little bit more in detail than other areas, and obviously you can download section number 5. You can download it. Obviously go through it at a slower pace if you'd like and read the text of the slides. It might actually benefit you a little bit more. Here's where I stopped, and this, I can't give you everything there is to know about SAP. In fact, you can take, I believe, 3 courses here and get a certification in SAP. Not a bad angle. Not a bad angle if you're a business person who wants to do hands-on implementation work and more technical information systems, information technology type of work. SAP is right up your alley because it's not technical. It's more business-ish. And we have all sorts of different classes here, actually. Some of them are more technical than others. Some of them focus on the business end. Some of them focus on the database part of it, the database kind of end to it. And it's an entire area that has a lot of growth and potential because it has a huge segment of the population, of the business population is using SAP. So to have those skills is, maybe about a year ago was quite unique. Now it's almost required. So it's not a bad thing to look into. So for those of you who have never heard of it, let me give you a brief overview of it and tell you what it's all about and show you some examples of how it's being used so you have an idea. And maybe it'll spark an interest for something you might want to get into. Don't ever say SAP. In fact, I hear students saying, SAP, yeah, I'm taking SAP. Will that SAP class work for something? And actually, if you're an engineering management major, you can take 3 SAP classes. That'll count towards the business, depending upon what, because we have some that actually fall into business. Some falls into information systems, information technology. Rarely would an SAP course fall into an engineering science because it's not, believe it or not, it's not that technical. It's something that anyone can probably pick up and do. All right, so what are we talking about? SAP systems, applications, and products. Some people actually are in the data processing kind of fashion, which is what our little definition here. This is our etiquette slide. what to call it, how to refer to it. Some people actually used to call it statistical analysis processing. It's really not really much of a statistical analysis tool. It's more of a systems application, products tool. And you can call it middleware if you want to, I think. But I don't know if it really technically falls into the middleware, if you're familiar with that terminology. I don't know if it really falls into that category at all. And how to pronounce it? S-A-P. Spell it out. Believe it or not, I can't tell you how many people have referred to it sort of like a syrup. You know, it's sap. Sappy is what comes out of trees. It's a syrup that comes out of trees. So anyway, that joke didn't make it too far. All right, so it actually quickly separates you in an interview if you go SAP. They're going to go, oh, you have no idea. Forget it. Right there. So it's an easy one to fix, actually. 4th largest software vendor in the world. This slide is actually from April 97, which is kind of far away. Now I would almost put it like number 2. I would still put Oracle above it. I think it's surpassed Microsoft tool sets. In fact, that's kind of dying out, actually. Oracle is still pretty strong. Computer Associates, it would be underneath it now too. So I would actually rank that with Oracle first, SAP second, I believe, in terms, only because Oracle's got a huge market share, and their database tool sets and add-on products and things, it's really a nice package deal. Like when people go with an Oracle house, they do everything Oracle, and for that reason alone, they're investing a lot of their assets into Oracle. So that's how they can actually kind of get a larger market share than another vendor that's going to work with a lot of different types of platforms, different components and things. So what are we looking at? Here's a partial client list. I like how it's just kind of populated. It looks like almost everybody is using SAP. Those are just, that's part. And again, this is maybe about 2000, 2001, 2002. I would believe is probably when that data was done. Okay, so before SAP, and this revision today, I actually don't know what the current revision is. So this R-3, do you guys know, actually? Is it 4? Are they up to 4 already? Yeah. Are they still on 3? Oh, okay. I think 4, I think some components of 4 might be already pre-beta or something, or might be slightly available. I know that they're probably working, as any other company would do. They're working on upgrades constantly. So systems don't talk to the extent processes required in spite of 20 years of IS labor. And systems still don't talk to each other, which is why SAP exists, which is why I kind of referred to it as middleware. It'll sit out there and it'll connect components for you. And it'll automate, streamline, take away manual labor. Because, unfortunately, the reality of the world is manual labor is slow. Humans are slow. Humans make errors. And we have to pay humans. We don't really have to pay computers to do the work. So if you can get the computer to do it and not the human, which is what SAP is striving at, then you can kind of make it more streamlined, make it faster, make it more error-free. So to fill in where systems don't talk and people don't want to talk or can't talk, we put in SAP. So it monitors in terms of hold points to ensure that procedures are followed with the disorganization of being part paper, part automated. So it does kind of sit in the middle of everything and kind of organize traffic in some ways. So it basically bridges systems and paper processes together. In fact, that's basically what we had to do before we had SAP and tools of that nature. And, well, this is a confusing little diagram, but it's basically just showing you processes, one process leading to another process to another process. You can think of this as business processes, a flow chart of how information might, how data points from an information systems perspective. This is showing you how data is connected together to give us the information that we're concerned with. So a lot of people actually, and this is the red lines in here, according to the legend on the bottom here. What we have here are batch files or batch processing in a legacy type of system with human glue instead of SAP or something else working in there. The red marks are the human glue. So process efficiency is pretty much the goal. If I were to give you one description of what it's used for, why it's useful, realize through the ability to reduce personnel requirements to perform a process. Transfers into processes that were able to meet customer requirements, hopefully, and give the entire system more functionality without making it a system. You're basically just gluing the pieces together, per se. And the key enabler, we have one system. We usually call it the SAP system. And omni-functionality, fully integrated, process-oriented, off-the-shelf solution. So we can kind of put these packages together, these systems together, and they can be multifunctional, and they can almost be generic in a lot of different ways. Because what we're looking at is just providing glue is what we're providing. So you kind of see it's broken down into a lot of different areas. This is how you can actually kind of take different SAP courses, depending upon a specialty area. Are you concerned with database processing information, statistical analysis for reports? Are you intercomponent, business logic? So many different areas that you can actually look at. So, And depending on what you have an interest in, you can actually kind of specialize your skill set, I believe, a little bit, given the opportunity at a company or given an internship or something that you could work with. Here's some products that are built off of this platform, and you can kind of think of it sort of like a platform. We have a bunch of generic systems that are built. We have customer relationship management, business process improvement systems, strategic enterprise management, business warehouses, and we're going to talk about warehouses, or I'm going to talk about warehouses in the next lecture. I'm going to cover databases and warehouses after this particular lecture to show you the power that IT has in terms of strategically aligning different types of databases together to create a warehouse to provide some benefit to the organization. And on the other side of the coin, outside of SAP, and believe it or not, that's all I've got on SAP. I mean, you actually would have to take a full semester course, I believe, to actually kind of get a better feeling for all of the different components of it, because it really is sort of a technical/business concept. But it's so integrated in so many different types of systems. It's a very broad subject area. So on the other side of the coin, we have the Microsoft Dynamics. We have Microsoft products. When I say Microsoft products, not so popular. Because I just told you, SAP, I would say number 2 outside of Oracle. Oracle actually performs some of these inter-process communication things between different components on the system. So Microsoft, what do they have to offer? Well, here's the Microsoft Dynamics. I'm not quite sure what the install base is. Not quite sure how popular. Works on Microsoft servers. And again, anything that's Microsoft oriented. I'm not a huge fan of Microsoft, but I don't want to, give them a negative impression either. Everything, however, and this is a true point, everything that works with Microsoft is Microsoft. So hard to take an Oracle system and integrate it with a Microsoft server products. Not going to work. Or if this type of system isn't going to interface well with anybody else, unless you're working with Microsoft SQL Server, Microsoft, hopefully you're getting the point. So if you're taking this route, you don't have any other choices, unfortunately. Oracle's not going to work on this. SAP's not going to work on this. So you have to take this route. It's kind of a vendor lock-in kind of situation at that point, because these systems are not cheap. Once the company has installed it, they're not going to move away from it. So you went and you got your SAP certification, and you go into this, oh, it's a Microsoft. Oh, no, you should use SAP. And they're not. You yell all you want and recommend all you want. It's not going anywhere. Just find another company to work for, because it's not going anywhere. Microsoft Dynamics, formerly known as the Microsoft Business Solutions, out of Great Plains. And I don't know if you remember a while back, maybe about 5 years ago, IBM started, and why they did this, I don't know, but they started advertising their business systems, their solutions, on the TV and on radio shows and stuff. I'm thinking, what consumer sitting at home watching television is going to go out and spend $200,000 to $300,000 on a Microsoft server solution? It's like, well, how many of these are they going to really sell through the television advertisement? But I think it was more along the lines of repositioning the company, maybe, to put themselves, and this was IBM actually that I'm talking about, that was putting themselves in the business machine, because IBM started international business machines. They were actually big servers, big systems, and they catered to the business customer. To put this on like a radio advertisement or TV, it doesn't really make any sense. I'm glad that kind of stopped, but I think it was more along the lines of giving the consumer a better perception of the company. It was probably a marketing ploy for some reason. And for about a month, we saw Microsoft Dynamics. Again, this is a pretty expensive system that works on a pretty expensive server that you don't buy to run on your home computer. The marketing guy who thought about advertising was probably maybe they had the same kind of notion in mind. I don't know what was going through their head really, but anyway, long story short, the Microsoft Dynamics, you can bring supply chain functions online, make information available to collaborative tools. You can put together a hub for buying, selling, trading things. Wherever your employees, vendors, and partners are, you can make the information available to them. It's kind of like what Oracle provides in terms of their web services. This is the Microsoft equivalent to that. Because The business portal functionality, the customer relationship management functionality, all of the different subsystems of this kind of brings together sort of an SAP equivalent kind of thing, because it puts it all on the same platform, brings it all together. But again, it's a totally different product. It won't work at all with an SAP kind of environment. Why is it good for small businesses? Well, we have hardware considerations and database requirements. The system actually gives you everything, which is nice. The price is not quite nice, and the capital investment's not nice. But it's like, you do it once, and you have everything, and the system will grow with you as a company. But it's not really feasible for small businesses. But neither is SAP, if you think about it. Neither is Oracle. So small businesses are kind of interesting because they have to start out piecing everything together themselves. And then as they're growing, what they have is not necessarily going to grow with the company. So in terms of taking this back to the strategic, how do we strategically use IT? We can't, if we're a small business, we can't do some of the things that big businesses can do, which is one of the barriers. It's kind of like the roadblock that small businesses run into. Is one of these days they're going to have to go out and spend $200,000 or $300,000 on a server system, or they're going to have to take everything they have and throw it away and buy new systems that are going to support SAP or PeopleSoft or something. And again, PeopleSoft is actually very similar to SAP. It falls in the same line, similar to Oracle tools, Oracle Developer. Oracle is funny because Oracle is one of those companies, you can buy a database from them. You can buy a web server from them. You can buy the human resource module from them. You don't have to buy the whole thing. In fact, that's a really nice way of going because piece by piece. Problem with the Microsoft end of it, it's the whole package. If you're a small company, you can't afford the whole package. You're going to buy piece by piece. So in some ways, the way that the technology is presented to the consumer or the business is going to determine what percentage of market share they're going to get and who's going to buy it. So small companies go the Oracle routes. The Oracle route is actually kind of easy to translate into the SAP route further down the road if they don't want to go completely Oracle, which is nice. You go to Microsoft route, you're stuck. You don't have anything, and you've spent a lot of money, and you have everything, but you have to stay that route. There's no changing modifications. The growth potential is sort of limited, I should say, so in terms of changing. Which, and personally, and from my own personal opinion, and this is maybe not even true, but I think that's why Microsoft hasn't been able to get very much of a market share, and why SAP is pretty much, I would call them number 2, or maybe number 1. I might be underselling them. They might be number 1 right now as a leader. So information technology for e-business, and this is an interesting concept. It's not e-commerce; it's e-business. So e-commerce and e-business are actually 2 separate models. Commerce is buying and selling product over the internet. E-business is building a business foundation, a business concept that's completely electronic. If the internet were to go away, so would the business. So eBay is an e-business, PayPal is an e-business. Barnes & Noble is not an e-business. Barnes & Noble does e-commerce. Amazon's an e-business. You can't, well, not recently, a long time ago, they tried to open up stores. In fact, we had Amazon stores in California, but they went away because the whole model shifted from a traditional business model to an e-business model, all online. But they're an e-business that does e-commerce. So if you think about the IT strategy for e-business, you're looking at systems that are going to support communication, that are going to support commerce, that are going to support the business components, supply chain management, customer relations, everything. And you're heavy duty on technology and you're heavy on information systems because you're completely electronic. Just because you run this way doesn't mean you don't have corporate headquarters. We have Google, Yahoo, we got all these people, eBay actually in California. We have buildings where people sit there and work. But they're not, you just can't walk. Well, you can walk in, go to a meeting, go to an interview, and you can work there. But the business itself, most people think, well, what's the business? Because then you got to define, well, what do you mean by business versus commerce? It's almost, it's kind of like drawing a gray line between the two of them. Without commerce, you don't have a business. If you don't have a business, it's hard to do commerce. So they're kind of almost sort of the same, but the terminology in terms of how IT relates to it, they draw a black line instead of a gray line. They separate the two. And they go, oh, that's commerce. Because commerce people who do e-commerce, like your Barnes & Noble, they have different IT needs than your Amazon. Because there's a totally different structure in terms of how the commerce is supported. And as an example, let's say the local Fry's store, not an e-business at all, but does commerce. So the latest thing now is everything has to be synced. So years back, in terms of how IT information systems were being used for e-commerce, we had the in-store, and then we had the website, and the website sold products. And actually, stores like Target do this all the time. Like, there's products that are available online that don't end up in the stores, and vice versa. You have inventory that's different online, and it might be out of it online. So it's almost like two separate stores. You go to the website, you look at something, and you can order it. But you're never going to find it in a store. So it's almost like two competitors all working under the same house. That's old, actually. Still around. There are still some systems around like that. But the main stores now, the main department stores, the main computer electronics stores, have taken the two and put them into one and have supported the in-sale store with the e-commerce environment and vice versa, because they are not an e-business, they are a traditional business. As an example, Micro Warehouse, maybe you guys have heard of this, it's like right off of 101 next to Mercado Theater. There aren't too many micro warehouses around. Very small building. Probably is more profitable than Fry's. Here's why. They have everything synced, and the way they have a lot of huge business clientele who won't shop at Fry's. Then you walk into Fry's, it's a half-day event practically. If you can find what you want, and then you got to go and you got to wait in line, and it's retail shopping is what it is. So micro warehouse isn't relying upon the retail sales, retail shopping people. Instead, they have contracts with other businesses that supply parts and components. They actually build systems. They build special gaming systems, support systems. They work with business customers to provide IT when needed, to fill in office buildings. They do all sorts of corporate company-related sales. Consumers can also participate in this. You can spec out a system through the internet, send it to them, they can custom build it for you. You walk in, you pick it up. Or you don't want to do the retail shopping experience. You pick out your products and everything, you pay for it. Oh, you just walk in the store, you go to the counter, you show your ID, and you pick up your bag. You're done. You don't have to go and actually look through the shelves and stuff. And the benefit of that is everything is linked, and they're not running it as two separate entities. It's actually one entity, one sales engine. Through technology, they've got the inventory online matched almost real time. So you walk in the store, somebody buys something, somebody's online shopping, it says now there's 3, oh, now there's 2. It refreshes and goes, oh, someone's buying it in the store. So you know that you can do that. If you did that at Fry's, won't work. Here's why. The inventory is not synced. You got the inventory here, you got the inventory here. It's two separate entities. Although they can say, oh yeah, you can go, but there's always that disclaimer on the bottom. Pay for it when you get to the store, because the store might not actually have it. Yeah, there's 3 of them over here at the store. You get there and there's nothing. That, people are relying, in fact, it's customer satisfaction that's basically earning them a lot of the market share, because it's there. It has to be there, because their inventory is synced up between the store, and they actually have accurate inventory going on, and it's synced up with the website, and it's streamlined. That's your strategic advantage. That's how you become effective in IT in the retail computer electronics market these days, is you don't have e-commerce. It's all the same. It's all under the same roof. Which is kind of different. And we also have people who don't have stores, that just do 100% e-commerce. That has a slightly different model to it, because we don't have to worry about the same type of customer. We have a totally different market with that. So tools for web page development, site management. Well, you've been staring at this for a few minutes, so I can kind of move on to it. And I haven't really talked about it, but I don't really need to, because this is all modern technology that's going to change next year. I mean, I'm sure JavaScript will stay around, Java will stay around, XML. If you are interested in learning web development, you're not going to ever probably work in it these days. It's all streamlined. In the old days when, e-commerce was, oh yeah, this is maybe about 10 years ago by now. People got into website development, waste of time. There's no more, you would probably make more money selling burgers over at McDonald's than you would building websites, because it's a given these days. In fact, the tools themselves, the packages that are being used for commerce, already have the website interface in there. You just install the module, it gives you the shopping cart, gives you everything you need, and it's all integrated with the database. And not to drown your hopes, or some of you probably do work in this right now, perhaps. There's still jobs in it, but they're more technically skilled jobs. So if you get into it, it's not a designer job anymore. It's, do you know how to program in Java? Do you know how to write in a scripting language? And then it's more hands-on, and it encompasses more outside of just the design and the construction of the web page. But that actually is kind of, that is, Flash is still popular, very popular. Dreamweaver, that's actually kind of current now that I look at the list. CGI, not so current. CSS is, cascading style sheets and so. But if you take a web development course as an IS person, that's generally what you end up learning are the technologies. So you can put the pieces together. So hardware considerations for supply chain management, another kind of system that you need to think about, and this is where the strategic part of it comes in again. Are you going to put everything on the public network? Are you going to put it on a private network? Is it going to be an extranet versus an internal versus an intra? So we have intra versus extranet. So inter is public, intra is private. So intra is the use of the Internet Technologies IP for internal communications. Extra, which is kind of the newest buzzword, is used for Internet technology and protocols for the internal and suppliers' communications. So it's now no longer just inside your company, it's into your company and the people you have invited to also be part of your company. They actually are calling that an extra. Well, it's intra plus extra stuff, extra people that are also involved in it. So logically, if you play with the words, it kind of makes sense. None of it is directly on the intranet, but it can be bridged or housed. So then we start defining the network as a strategic alliance. So if we take and create the network, we put the extranet in there. Then we can build applications using SAP, Oracle, all these other tools that I've been talking about, and bridge the gap of communication. So your supplier actually becomes part of your company. This is where they come up with this enterprise concept. So the enterprise is you, your suppliers, your customers, everybody else you've got extra connected to is your enterprise. Why they came up with an enterprise for that, I don't know. But sometimes, they started out calling it a digital firm. Nah, I like enterprise better compared to the options. I'm not going to go through all this, but if you're an IS student, you've taken, or an IT student, you've taken WAN, LAN, MANs, all the different types of configurations and the WAN technologies. We have some different options when it comes to the technology part of it. The point-to-point leased lines, a little bit more secure than the public switched lines, but they're more expensive. So you take a networking course, you look at frame relay versus ATM versus all of the other ISDNs versus all of the other options you have, and you figure out from cost advantage and from networking perspective, how should we assemble it? And we create the concepts with the technology. And we put together what it is we need so we can use it effectively. So global considerations also for using these SRM, supply chain management and ERP systems. Well, obviously we can connect people that aren't local. We can go global considerations for time differences, language issues, currency exchange rates. We can build it into the system so that we have all of these problems solved, hopefully. Different accounting systems, security restrictions, culture and religious holidays, and things of that nature can be built into the system as business logic. And that's where we kind of come up with a lot of the logical, when they say business logic. Well, I'm going to build business logic. Well, it's, all of the different considerations, regulations, rules, taxing, things of that nature that might fall into that category. So that was the end of Lecture 5. That went into some of those systems in a lot more detail. we're not quite done for today. I want to start number 6. And number 6 is talking about this concept of business intelligence and building that business intelligence into the system and using IT to support it. Because nowadays, business intelligence is one of those strategic advantages that companies are using. And if you're not using it, and this is kind of like, what happened years ago when if you weren't on the internet, you weren't a company. Now, in about another 5 years, if you're not using business logic, you're not going to be around because businesses have become a lot more successful due to this business logic, and they're a lot more competitive. So, not to put down your hopes of becoming an entrepreneur, opening up your own business. Some of you probably are thinking about that. Maybe you are doing it already. Actually, I know a lot of students here. They have their own websites and stuff. Thing is, though, it's a lot harder than it used to be. And you've got to really think about the business logic and think about how you're going to logistically plan growth and how you're going to actually compete out there. So what we're going to look at in this particular lecture is describing the key characteristics of a relational database and look at databases and data warehousing in terms of building. And this is not going to be a replacement again for a database class. I'm going to give you about almost the same amount of information I gave you on SAP, maybe a little bit more on databases. Defining software components, it's not a bad idea to look at, from a software perspective, what's involved in terms of putting the IT together, listing and describing the characteristics of a data warehouse, which I think would probably be more interesting to you guys, because everyone's heard of, have you guys heard of databases? Have you taken a database? Show of hands, I've taken a database class. One person. One person? Seriously? You've taken a database class? No? Okay, then I'll go over the database stuff in a lot more detail. I've only got one person, or one person who's not afraid to raise their hand. All right, so we'll cover databases then, and so this is going to be a 2-part actually. I'm not going to finish it all today. Describing the role of business intelligence, and then listing key considerations for information ownership. And there we go, tiny piece. So this is kind of the overview of what we're looking at. And can companies keep your personal information private and secure? That's a big issue. So the Sarbanes Act and some of the other ones of the 2000. This is 2011. So I'm thinking, man, 11 years have gone by since the year 2000. Time just seems to fly. However, these acts aren't that old. These are Data Protection Acts, Sarbanes Act, Patriot Act, all of these acts that were put into place to protect consumers. Some of them have been effective, some of them have been a distraction, some of them have really blown up into other problems. One of the biggest important ones was data. And what can companies store on people? What can they do? Because what ended up happening as soon as databases entered into the business logic, all of a sudden we have everything. We're storing full social security numbers, names, addresses, telephone numbers. That just screams of identity theft all over it. I mean, and then, do consumers really want companies to be keeping all of their data like that? And then are the companies actually reporting everything that they should be reporting and protecting the data? And so some of these acts were initiated so that companies were held liable and more responsible for what they were doing, not only for their reporting behaviors and their accounting, but also for the management of information, which was a big issue. So they're large repositories with detailed information in them, very dangerous. You'd think these things would be under lock and key, but some databases aren't, which is kind of scary. I mean, the company is in control of it. The more companies storing your data, having a database, the more times your information is duplicated out there, the more likelihood you're going to have something stolen. So. And I think I already scared you a couple weeks ago. I think it was this class, maybe not, about Google Voice. Yeah, I scared this class. I've been scaring all classes. It's a true story. When you use a Google Voice, if you miss that, it stores the data, puts it in a database, gets data mined. So you called up, let's say Verizon, pay your cell phone bill, give them your credit card number, all the information to process a transaction over the phone. It gets translated into data, housed, and then somebody mines it, and within seconds, you can actually have that information stolen from you, and someone's going to use it to essentially process a transaction somewhere instantly. which is kind of scary because they don't tell you when they give you that free Google Voice number that they're actually data mining your data, and that your data is publicly available for anyone who wants to go look at. So it might be interesting to set like rumors and stuff, you know. I don't know, set bad information out there. I could think of kids doing this, just going out there, yeah, there's going to be an earthquake tomorrow, and it's going to happen at this time, and like have like 20 of their friends call up over Google Voice and see how many things make it to the news or something. I don't know. All right, so organizations must protect the information from theft and loss. They're now, as of the year 2000 and above, they are now held legally liable for anything that they do with the information. They can't sell the information. They can't lose the information. They can't they can't keep information that's wrong. And this is one of the main reasons why healthcare and data records, medical records, are not available on the internet yet. Because what happens if you say something? How many people gone to a doctor been misdiagnosed with something, or there's been a clerical error, or there's been a problem. In fact, this happens in American hospitals all the time. You go in, you're going to have your arm worked on, and they end up taking your leg off or something. There's cases like this going on. Not as much as in the past, but, of course all the bad stuff ends up making it to the public media. The good things never happen. You never hear about the good surgeries they've done. It's just the bad ones. But they can't afford to have the liability of you being turned down for health insurance because some clerk accidentally checked the wrong box on the form and said you had diabetes. So now you have a pre-existing condition and your health care provider is not going to provide you with insurance or something. And I don't know if that's really the case, but as an example, so medical record, you can't put those online. There are some, like Kaiser local hospital, they are actually making all of it, but it's within Kaiser network, because they can control the data inside of their network, and it's not open to the public, by the way. It's just open to Kaiser customers, patients. So that actually, they're one of the first hospitals actually that are taking that strategic advantage of using, electronic medical records. Makes it easy. You can schedule appointments online. You can talk. Because the other thing, in the American medical kind of field, you go to one doctor, he has no idea what the other guy said or did or what. And it's like if you see someone new, all of a sudden you got to explain everything all over again. They have no history on you. They have nothing. So it actually helps them treat you faster, essentially. Many bad people want to steal your personal information. What do companies do with you do business with? Might not actually store your information correct. So big information loss examples, card systems, 40 million. Actually, this happened recently with Discover. I think Discovery is actually out of business at this point. They had the numbers stolen or something. I can't remember what happened. They had a network leak. Somebody was able to come in, steal all of the numbers, mess up the billing, essentially. Card systems, Citigroup, 3.9 billion customers had an issue. DSW Shoe Warehouse had problems with their credit card processing. In fact, I believe that one was because they were storing the information too long, which happened a long time ago. Obviously, they've grown back because there's DSW shoe stores everywhere, out here in California at least. So Bank of America actually had problems. Wachovia had problems. Almost every company has had problems and losses. It's a big issue actually, which is why the government actually kind of stepped in and said, hey, wait, we have to provide more regulation, more control, more safety on customers' data. So some questions to ask yourself. Everyone knows someone who has been a victim of identity theft. It's been going on way too long. Everybody, so at least one of you in this room has had. Probably estimate more. But you do protect yourself in identity theft. Sometimes you can't. Here's the problem. So it's up to the businesses to actually protect the data in the databases, because it doesn't really matter how you stay off of the internet. Even if you don't use the internet, your information is on the internet. If companies are taking their business system, the entire last lecture we just looked at, and they're making that information available on the internet, it doesn't really matter if you as a customer ever used it that way. It's there, so it could be an issue. And then, how many organizations have your credit card number? How many times have you used your number? What do you do with credit cards? You use them. So you give it up to people in a restaurant. And sometimes, actually, this used to happen, and I'm glad this stopped, but travel companies, or people who travel, there used to be a report that came out that was saying that people that were using their cards at travel agencies were at a higher likelihood. So you lowered your limit because when you went on your vacation, they knew you were on vacation. So they could just start charging your card up while they're laying on a beach, not worrying about what's going on your credit cards. So anyway, that was more scare than actual reality, and that was like many, many years ago. Okay, so what we're looking at in terms of business intelligence and databases, we have many IT tools to manage, organize the information. A lot of them are database related, which is why we're talking about databases. We have online transaction processing. Well, here OLAP actually, more so than online transaction, OLTP. Usually the abbreviations are commonly used. You'll hear the abbreviations more so than the actual words spelled out. Gathering, processing information, updating existing information to reflect the processing of the information. So in terms of transaction processing, the organization of it, the automation of it, turning into the business intelligence is that area in which online transaction processing would fall into. That would be technologies like EDI, electronic data exchange or inter-exchange, electronic document exchanging, the whole XML movement that's going on in terms of electronically processing transactions and records and things. The more you do that, the more likelihood of exposure, the more likelihood of saving the information, because you're either going to have it in a temp file, an XML file, you're going to have it in some sort of a saved data piece. And then when we see later on, we have data mining, data warehousing. Well, that itsy bitsy little piece of data that gets saved here, ends up over here, ends up over here. So the data itself gets duplicated, saved, archived. It's kind of like when someone said something one time, all of a sudden it's repeated over and over and over again. It's like, that's why some people don't like to write emails, because then people forward the email everywhere. So if you have something really important to say to someone, you always say it in person. So they can't take your verbal word and copy it all over the place. So-and-so said that. No, I didn't hear it from her. Oh, okay. All right, online analytical processing, OLAP is probably a more common word you're probably familiar with. Manipulating of the information to support decision making. OLAP decisions give you, as an example, what to price airline seats at, given the demand, given how many seats on a plane are sold, given how soon the flight's going to leave, given the cost of gas, given whatever kind of information they want to put into that decision. The information is going to be processed, and all of a sudden this price is going to spit out and say $49.95, or the same seat would cost you, another day $89.95. These are Southwest prices, by the way. So might be add a 2 to everything, or 200 to everything for another example. So in terms of online transaction processing, what do we have in that? We have the support for the operational processing, which is why I used EDI as an example, the technology of the data exchange using an XML type of format. XML, if you're not familiar, is a markup language for data. It's kind of like HTML is for presentation, but XML is used for data processing, for almost database-like kind of capturing of information. Sales orders, accounts receivables, support for operational databases, database management systems. That falls into the online transaction processing, because we can take automated data pieces and put them into a database and save them for later, because in the hopes of being able to do it again legally, but be able to take the data, capture it, save it, so we can use the customer's information again. So whenever you've gone back to a website and say, hey, are you really a customer? You put in your name and your password, it should hopefully find you in the database, and you don't have to duplicate all that information. Well, if they're smart, they can actually take that system and track how many sales they've made from you, and send you 10% off, which is what they do now, or 15% off coupons or something like that. Because you're a loyal customer or something. They can house that and use that information for marketing and other purposes, which some people might argue and say, well, how is that different than using my information or selling my information in other ways? Depends on what we've consented to, actually. And which usually now we see boxes that say, are we allowed to send you information? And usually they're all checked by default. You have to uncheck them or something. Because that's what the Data Protection Acts, that's what those acts of the 2000s, some of them actually made companies give you a choice whether or not you wanted the junk mail from them. So, which is not bad. OLAP itself, in terms of the online analytical processing, helps to build business intelligence, as I mentioned with those airline seats and the pricing. Support for data warehouse data mining tools, receiving data from online transaction processing systems. So the two concepts actually kind of work together. The transaction gets processed. It gets put into a statistical OLAP analysis tool that takes and determines real-time pricing, that takes and determines scheduling. You know, in fact, I like it, you know, you can figure out if something's on time. You know, is a bus on time? Is a train on time? Is, you know, by a lot of these like mobile apps that we have on our phones now, we can actually see, are they behind schedule or are they on time right now? And then, you know, all that information is coming from an analytical analysis that says, well, it left New York at this time. We're not on schedule. You know, oh, we know we're not on schedule. So we can easily tell someone who's thinking about driving to the airport that your plane's going to be late, kind of thing. So kind of gives us better customer service, customer applications. So here's all the pieces put together. The OLAP and the online transaction processing gives us our business intelligence. In fact, they kind of sit on this side we have the information, on this side we have the intelligence. And we think, well, what is business intelligence? This is a great way of describing it, actually. It's taking the data, putting it into systems, creating information out of it, taking all the information, adding it together, and using it with OLAP. So the transaction processing, on the bottom here we have the online transaction processing, OLTP, and on the other side of the fence we have the OLAP, the analytical processing part of it. And it's kind of, you actually do have to kind of draw a line down the center of it and say, this is the transaction processing, this is the processing that turns it into the business intelligence. And so when we're talking about business intelligence, we're really talking about this data warehouse on the end, which is why when everyone says data warehouse, in fact, outside of object-oriented anything, data warehouse is the most commonly misused word. Say, well, we have a data warehouse. Oh, it's in the data warehouse, so let's just query the data warehouse. Everything's data warehouse. And in fact, that's actually kind of going away. This was maybe about 5 years ago. Everything was OOP, OOD, and data warehouse. Because those are like the buzzwords of the future. Well, here's the future, and they're not buzzwords anymore. So now we have OLAP, SAP, OLTP, transaction processing, TPS systems, CRM, ERP. Those are actually kind of current. I'm waiting for like more human-like acronyms to come out that actually explain what all of these little things are actually doing, which might make the whole concept a little easier for a lot of students to understand. I'm not going to go through this, but you can download the slide set and take a look at it and read through all of the different components. The main point to get out of it is this data warehouse concept. And the data warehouse is information used for decision making. We don't keep data in data warehouses. We keep data in databases, database products. We take all of the data that's on all of these little data products. We do OLAP on them. And we're using it like a data warehouse. It's kind of like when you go into Costco. It's a warehouse. You know, you buy food and clothes and shoes, and you buy everything in the warehouse. But each one of the products that's in there is coming from a different source, usually, or many different sources. And your OLAP tool is your shopping cart as you're rolling down the aisle and you're picking up your database items and you're putting it into your OLAP tool and you're going up to the register and you're paying for it. And your OLAP tool is telling you, make that airline flight seat $25. Or it's the last seat on the plane. We're never going to sell it. You've got a single customer who wants to sit in the middle aisle there. Oh, sell it to her. Give her a good price on it so she buys it. Kind of decision making that happens. But they have to look at, you know, how many seats have sold, when did they sell, what percentage of the plane is still full. And now what they do actually is kind of interesting is airline companies selling passenger seats are now selling cargo. And that actually happened from No, Continental. Continental was the first company that did that. It said, if we can't sell our airline seats because United's taking all of our businesses a long, long time ago, let's sell the cargo space. A plane's a plane, right? It doesn't really matter. So they can only put so much weight down there, which is now why you have to pay for your baggage. The heavier the plane, the more gas it takes, actually, aerodynamically. So the more expensive it is. And they can sell, and they are selling the cargo space. So you have to limit what the customers are taking. If the customers are going to throw everything on the plane, then you're not getting a good deal as the person selling them that seat, because they're taking up all that space down there that you could be selling to somebody else, for FedEx. Right? Why run a FedEx plane the same route you're running a Continental plane when this Continental plane's half empty? Oh, load up the bottom. So that plane is full, whether it's full of passengers or full of cargo, which is kind of the new game that's going on, which is, and plus it's a great way for them to make extra money on you, charge you $25 per bag or something. The airlines that aren't doing that aren't selling cargo. So if they're just selling passenger seats, then you can probably take on as much luggage as you want because it's extra space. They don't care because they're selling all the seats and they can only have so much weight total. So anyway, that's why they put baggage weights on everything too. But if you're an exceptionally large person, you pay the same thing as if you are an exceptionally skinny person. So they don't charge you per weight. Although I don't think they could do that in this country. I have actually seen it somewhere else. I took a plane out of Hong Kong, from Shenzhen into Hong Kong, and they weighed us. We had to step on a scale. And that was amazing. I'm like, wow. So I don't have to pay as much. And they weigh your baggage. They weigh you and they weigh your baggage, and they charge you for the airline that way. There's a small little airline company. It was running, it's like a 10-minute flight. It wasn't even that long. And they were paying per weight, which makes sense if you think about it. You can't get away with that in this country. I don't think that you can legally do that. I don't know. You can't discriminate in the country, so they were definitely discriminating. Luckily, I didn't have anything but a golf cart. I had golf clubs with me that were kind of heavy. They were heavier than I was. So, all my luggage. So anyway, business intelligence. Brings us to the concept of the database model and the relational database model. Now, most of you are going, oh no, I don't hear about database. Only one person in here is taking a database course, so you can't be doing that yet. So database is a collection of information that's organized and accessed according to the logical structure of the information. Not a technical concept, it's actually a business concept. In fact, the relational business concept and the design is it's not really software engineering, in my opinion, or even computer science. It's business. Because what you're doing is you're logically organizing. It's kind of like a file cabinet. That's business. That's not software engineering. You guys are familiar with the vanilla folders. You put little labels on them. If you've ever worked at if you've ever been to a dental office, some of them still do this. They go, oh, what's your name? Open up this big old drawer and pull out your file. And go, oh, yeah. Look at that. You were here 10 years ago. And they get all the information on you. Now, hopefully they're not doing, dental offices are still doing that, local small people. Other people have it all electronic. And how do they do it electronically? They implement it in the form of a database. And the relational database is the tagging system. The relational part of it relates the data with other data. So we can have bills, pieces of paper, notes, appointments, future appointments, past appointments, all related to other things that are associated with you as a customer that are all in there. So the relational model is a series of related two-dimensional tables or files, I'm going to think of it that way, for storing information. So the relation is a table or a file. It's the vanilla folder that has all the paper in it. That's the relation. And most popular database model on the market, it's the only one that's actually truly available in terms of modern generations. I can go through first, second, third, fourth generation databases. We're still just on the third, which is the relational model. People keep saying object-oriented databases. We don't really have any object-oriented databases. The technology is not there yet. So it may be in the future, and it's probably going to be Oracle that comes out with it. All right, database characteristics. So we have the collection of of information. It's created with logical structures, includes ties. Those are where we get the keys, foreign key, private. You don't have to know anything about databases to kind of understand what the concept's all about. And that's where those keys come from, candidate keys, so they call them. Sometimes foreign key, primary keys. You guys probably have heard of those kind of things. Include, you can also build in integrity constraints. In fact, that's where the business intelligence comes in. That says, we can't have a customer in here who's not a customer. We can't have dependents in the company health insurance policy for employees that don't work for the company. If the employee's gone, so are the dependents. So logical things determine the constraints or the integrity of the database. The tables of data related through common keys or identifiers. Those would be the primary keys, secondary keys, and stuff like that. The database is a collection of information. Here we have, a retail company. It looks like we have order file, order table, employee, truck file, customer file. These are just like files in a file cabinet. So we take and get rid of the file cabinet, save the space, put somebody's desk there instead. Take all the information, put it online, put it into a database. Now that it's online, we can take it and build it with other people's information. That creates the warehouse. We still have our database. They still have their database. Well, we can abstractly put them together. We can also put them together with software. There's data warehouse type software. There's also what we have now, the cloud. So are you guys familiar with the cloud? Are we in the cloud now? No. I don't know why they said cloud because, all right, so cloud, in my opinion, when I look at a cloud, I see fuzz. I see almost like rain, sometimes clouds are dark, they're black, sometimes. Rarely do we see nice, white, beautiful white clouds. On a cloudy day, it's going to rain usually. Those are rain clouds. So they're holding moisture. It's not something I can kind of see through clearly, usually. So why do they call it a cloud? What they did is they created a network that seamlessly connects everybody together that's clear, that you can see through. It's a kind of contradiction in terms. Plus, when your head's in the clouds, you're in a fog, right? As the old expression goes. And when your head's in the cloud, in a cloud network, you're not in a fog. It's the exact opposite. You can see clearly. In fact, you have more accessibility to more information that you never had before. So, the guys in the airport, and say, to the cloud. Yeah, so they can go watch their television. They can get information and stuff that they don't have actually access to right now. They have to go to the cloud to go get it, Anyway, the cloud is nothing more than common shared space. And tools that put all that common shared space information together. So Google's cloud is being able to take a voice call, translate it into data, archive the data along with other data for like videos and for emails from Gmail and from uploaded this, uploaded that. It's content, essentially. Taking content, organizing it in a database. Content from all sorts of different sources. Making it searchable, making it accessible, making it clear, easy to find, organize, all together and shared. This cloud's all about sharing. Which is kind of the opposite of the word cloud, in my opinion. So I'm like one of those people out there going, why did you call it a cloud? I'm hoping they're going to change that and come out with a different word for it. That's fuzzy, unclear, and rainy and drippy and dry, drabby. It's like winter. It's summertime, we don't have clouds out there. Nice, beautiful, sunny day. There's no clouds in the sky. So it's cloud-free. So anyway, it's contradicting in terms. But going back to the reason why I mentioned it, was because we can take and use cloud technology, which is sharing data, essentially, which is going to replace data warehousing. I mean, it is data warehousing. Data warehousing, you don't make a data warehouse from scratch. You can't make a cloud from scratch either. You have to have everybody a member of it. Everybody supporting it. Everybody putting content into it. Database content, personal information content, all gets put up in it. It's readily available to anyone. It's really a collaborative effort, and so is a data warehouse. So when you can collaboratively get things together, then you can take and cross-reference people's medical history, which you can't do anyway, with people's dental history, with people's life insurance policies, with people's driving patterns and driving accidents. And then you could really put an assessment on them and say, instead of giving them a credit score, give them a life score. And say, hey, look, you're doing good. You only got into 5 accidents in your life, and you've had braces, and you don't have any medical problems. And you can actually rate and judge, actually analytically use OLAP tools to go in and assess information about those people, given all of those different pieces of information, kind of like what credit reporting companies do. They have OLAP tools that go through databases. What are databases? Employment records from the Social Security Department. How many years have you worked? How long have you been on your job? What are you making? With creditworthiness, all of the credit card companies, and maybe you have issued credit. How much credit do you actually have? With how old are you? Have you been to school? What degrees do you have? What are your driving patterns? All of a sudden, you get a credit score that comes out of it. So some people that might have a lot of cars but don't have any credit on the cars might have a lower score than someone who's maxed out every card they have possible, but they always pay their bill on time. Has a higher score, actually, which is kind of counterintuitive if you think about it, because those people don't need any more credit. But that's how the system works. But they can actually take all the bits and pieces of information, put them together, and assess, which is kind of like what cloud is doing. So sort of working very similar to a data warehouse in terms of that type of processing, because it's putting things together. And so here we have a collection of information on the slide that you've been looking at that gives us our database. We start taking databases and putting them together with other databases, then we get the data warehouse concept. But we just can't go out and build a data warehouse by scratch. We have to have data put into it. We have to have databases. So we want to create a logical structure. The more emphasis, more focus we put on the structure, the easier it is to combine it, because we know what it is. We have to have self-identifying data. Because if we put medical history and dental records and employment history, we have to know what it is, to put meaning on it. So when we apply our business logic, we're making decisions based on a science instead of flipping a coin or something of that nature. So the data dictionary contains the logical structure of the information. It tells us what we have. It tells us this database has employees and truck information in it, and this is what we've defined. This is a float, this is a double, this is a date, this is a string, stuff like that. And then we have these keys that I mentioned. The keys link everything together. So we have tables of information. Tables are files, folders, if you want to think of it that way, almost like directory folders on a hard drive. Uniquely describe each one of the records that's in there. And so we use a foreign key that says, in fact, you get this all the time, because people say, what's your social security number? Well, now they don't. What's the last 4 digits of your social security? Now they're not allowed to actually store your social security number anymore. But now they'll ask you, what's the last 4 digits of your social? Oh yeah, please sign the attendance. Is that the attendance? Yeah. Forgot about all my, oh yeah, you know what? Let me take a break right now, actually, now that I've lost my train of thought. Next week, I forgot about all of my administrative announcements I was going to make. Next week, I'll be having a little review of the midterm. So it will be a take-home exam. I will also be introducing the CSLO essay, which will be an essay, but not like what we've had before. That won't be due, the essay won't be due until the end of the course. The midterm will be due in 3 or 4 weeks. We'll make sure that we have the EMS database working properly so that we have an entry for it and we have the ability to upload it, because we want to sort of collect those before the end of the course. And I'll go over, I haven't written it yet, I'm going to write it this weekend. So I'll go over exactly what's going to be on it, what you need to do for it next week, as well as tell you where to download it from. I'll probably put it on bhacker.com. But it will also be in the ITU EMS, because that's how you'll submit it. And what was the other thing? I think that was it. Anyway, so I don't remember that. It was a slight distraction, but at least I remember to tell you. So that's going to happen next week. You'll have 3 or 4 weeks to turn it in. The final exam will be, that's what I forgot, the final exam will be an in-class exam. So you will have to take it in person. And it'll be a multiple choice or short answer type of exam, whereby the midterm will hopefully be an activity. I have to dream up something. It'll be a comparison and a contrast between something or something. Or maybe I'll have you put together a technology plan or something. Or I don't know. I'm still kind of trying to come up with ideas. Something that is fun, educational, and not like a boring writing assignment. Because that's what the CSLO essay is about, boring writing assignments. So I don't have to give you 2 writing assignments. So anyway, just in case you had questions about that, that's what's going on, and I'll have information next week to announce that for you. And I'll go over it for you as well, tell you expectations, requirements, and stuff like that. Okay, so going back to the database lecture already in progress, we have the primary key. So a primary key is a uniquely identifiable piece of information about someone, like a social security number, like the last 4 digits. And when it's used in the main table, like the employee table, it's primary. When it's used in another table, it's always foreign. So as an IT person, if you think about the concept, the keys, the only thing you really need to know is that the keys put everything together. And it's called a primary and a foreign. And that's how you're linking all of the tables together. And we have that key kind of concept. It makes it a lot easier because we use the keys and we do queries on it. So if you go back to the old dentist's office with the file cabinet, it's really hard to actually have, let's say, a sale on teeth cleaning. I don't know if they ever have sales on teeth. Actually, they do. They have sales on teeth cleaning. I always get the flyer in the mail. 50% off or free cleaning with your first exam or something. But if you don't have all of the information about your customer, who's been in here last, who needs a teeth cleaning, you can't find that out unless you go through every one of those single files in that file cabinet and figure out by hand, human labor. So as a start, databases came around to automate it. So now you can just do a query on the database and say, all these people haven't been in here in a year and a half. Let's send them a coupon for 50% off of teeth cleaning. Let's get them all in here. And we can easily put together a mailing list like that. And you use the keys to put everything together. Say, give me the last date they were here, and everybody who hasn't had a teeth cleaning in over a year. And we're going to use that. So we can build integrity into it. So we have this thing called a constraint, or built-in integrity constraint, and integrity is nothing more than rules. So rules to help ensure the quality of the information. And this is actually kind of a problem still in database design these days. Websites collect all sorts of information. And they have all sorts, but how many databases you get to and you say, oh, wow, all these telephone numbers are the last names, or then no one's given us a real telephone number, and we're using this information to process an invoice. So now if you go, and a really good example of this would be the United States Postal Service database. If you've ever used like Priority Mail, they have programs, you can print out your own label kind of thing. If you've ever done that, you fill out their form. They actually go through and verify the address and confirm it, that it's a real address. So your package won't get lost, which is great. Because the integrity constraint that's built into the system, before they put the information into the database, they're checking it, validating it, making sure it's real information, so that and then it will correct it. In fact, I've seen it sometimes add more digits or change the zip code or change the street from a way to a drive to an avenue or something that matches the records correctly. So it ensures that not only is your package going to arrive correctly, but the data that's being stored for that package is actually correct. Because what you don't want is to build decisions off of bad data. So technically, they could actually do some data mining. And when I say the word data mining, it's nothing more than running a query / ability to get information from this database. So when you do that, you want to make sure it's like garbage in, garbage out. You want to make sure you're getting out good stuff from good data. So the data dictionary, for example, defines the types of the information, the numbers, the dates, so forth, the keys themselves, primary key, foreign key, kind of link the data together. And as an example on the bottom, a customer number in an order table must also be present in the customer table. So we have consistency and those constraints, and we can build it. And then we have this thing called a database management system, and that's what Oracle is, actually. It's the software. So the concept's the same. We have different software that runs it. We have Microsoft Access, MySQL, Oracle, SQL Server. Nothing more than implementations of those concepts I just gave you 5 minutes ago. They actually have other things too. They have reporting tools, query tools, graphs, charts. Sometimes they have like web interface tools to it, so you can build a website easily. Shopping cart tools, credit card processing modules, all sorts of different things. Depends on the vendor. And that's how you get the differences between your Oracle people versus your MySQL people, and what purpose you're using the tool for. So it helps you specify logical requirements of the data, access, use information in the database. Here we have, it's really hard to see this stuff here, but as an example here, creating and changing the logical structure of the data. You do it through the data dictionary, the data manipulation, application generation, application tools, data administration, all going through what's called a database engine, which is really part of this big circle they draw you on all the charts that says database. And it kind of looks like, a storage, something like a storage canister, usually when they draw pictures of databases. That's all it is. It's just a storage mechanism. It's like saving a file, but you're saving it in the database or in the cloud. Actually, you can kind of think of the cloud concept as a huge warehouse, actually, if you think of it. So the 5 components that we're looking at, and this is kind of a review of what's on the slide right here, but you can't read the writing on the little picture. We have the engine. We have the definition system. We have the data manipulation system. That's the query language. That's your ability to update the data, change the data, get data out of it, get information out of it. Application generation system. That's for your form generators, your report generators, all of your different tools. And your administrative system, which allows you to set usernames, passwords, access rights, and things of that nature, set security, stuff like that in there. And here's a bigger picture of the smaller picture you saw on the first slide. And actually, believe it or not, I just went through all those 5 parts, kind of, and showed you. And there are some further examples if you want. You can download the slides. I can go through this lecture 6, actually. So the engine itself, we have some characteristics, and I think what I'm going to do is end after I go through the 5 parts of the database, because it's a good stopping point, because then I'll talk about examples of data warehouses next time and put it together. And I'm actually going to try to bring in some cloud computing information, because I've had some people request that, actually. And it's not currently in my slide sets, but everyone's heard it at this point. Everyone's like, semi-familiar with it, but nobody knows what it's all about. So I think it might be interesting. So I'll try and bring that in as well. So I have a lot of homework for myself this weekend. So we have the engine. We have the physical and the logical view of the engine. Because it's nice and easy to say it's a database, but it's kind of more difficult to actually kind of define what do you mean by this engine. So the engine accepts the logical requests from the other parts of the system, kind of like the engine of a car, actually. So people are, what part is the engine? It's the core, maybe it's the cylinders. I don't know. It's the piece that's holding everything together, and it's providing the space, the space to store the tables, the space to store the reports, and all the functionality, and bringing it together. So the physical view is how the information is physically arranged, how it's stored. That's that table abstraction or the file abstraction. And the logical view is how you need to arrange it to access the information that you need. That's the constraints, the keys, all of the different other components that make the physical view usable. So through the logical view. And the definition of the dictionary is nothing more than, and this is where people kind of, in a real database class, they kind of fall off a little bit because they go, what do you mean? Dictionary. It keeps track of the format, the data types, the information about the information in sort of a dictionary. It's going to think of it sort of like a repository of terms. The first name is a string, let's say. Birth date is a date. So it's keeping track of your definitions. That's why they call it a dictionary. Helps create and maintain a data dictionary and structure of the files of the database. So the subsystem would, for example, help you define field names, data types, forms, default values, if any were required at all. And the manipulation is the query engine. It's the SQL. It helps you add, change, delete, put the data into the database, get the data out of the database. And usually database classes, they break that off into two types of manipulation. It's either going to be DDM, data definition, DDL, data definition language, or DML, data manipulation language. Whether you're defining the data or whether you're manipulating it. To manipulate it, you're changing it, updating it, getting it, deleting it, using it, hopefully, manipulating it. Most often is the primary interface. So when you work with databases, normally it's one database for the entire company or for the entire group. And then you have application 1, application 2, application. Everybody's working with the same data, hopefully. And you don't have database 1, database 2, database 3. You're just a 1. And the interface is the SQL language. It's the manipulation language or subsystem. And when I say SQL, it's usually database people use the SQL. If you're writing an interface, a website that's going to use the database, you're going to send commands back and forth to the database. They're going to be SQL commands. And you're going to house them in some sort of a format that's required for whatever tool that you're building this interface with. So it includes also views, report generators, query by example tools, SQL query languages, stuff like that. So the view, it allows you to see the contents of the database file. And this is actually Microsoft Access. And it's looks like a spreadsheet, actually. And actually, that's why I don't really like Access, because it's very confusing to, especially ITIS people who aren't like computer science thinking. It looks like a spreadsheet to me. And so people think there's an order to the data, and that, but we're missing the A's, B, C, and we're missing the numbers on the columns. And we can't get at the data. We can't say, well, what's an A13? We can't take A13 and add it with A14 or something like that. It doesn't work the same way. But Microsoft makes it look like it's the same thing, which is weird. So the representation of data in a database from Microsoft's perspective is skewed because it looks like Excel. So the view allows you to see contents of the database file, make changes, query it, find information that's particular towards your use. It's your view, sometimes coming out with a report or a form or something of that nature. The report generators, these are very popular. In fact, there's third-party companies like Crystal Reports. I can't remember if they're still called Crystal Reports. I think they were bought recently by another company. That, but most people have heard of that because they were Crystal Reports for a very long time. They create a report generator. It's an application that connects to databases, any type of database. So connect to Oracle, MySQL, Access. And the tool's the same. It just goes and queries the database, gets the information, and presents it in a report. So it's kind of like a word processor for reports, actually. And helps you quickly define formats, information. Now, if you go with the Oracle route, they have form generator, report generator. They have all these add-on products. In fact, they even have Oracle Developer that allows you to kind of go through and create your own interfaces, your own applications. So kind of, working with databases kind of is a cross between application development and business logic, business intelligence, all in one. So it's usually a little less software engineering type, more business, more ISIT. So query by example tool helps you graphically design the answers to questions. You're basically using a point and click, a drag and drop kind of technique to run a query because you don't want to necessarily type in, select star from something or other. You don't want to type a query in there. Instead, you're using an example of the data that you want, and you're kind of building it graphically. And then we have SQL, as I mentioned so far. And as standard query language is what it stands for, performs any task. In fact, you can interface completely with the database. You can build it from scratch using SQL. And it's used typically by IT people. Because here's what ends up happening. You're in IT. You're not doing software engineering. You're doing IT. You're doing IS. You're building an interface that's going to have to talk to this database somehow. Even if you're using like Visual Basic or something, or if you're using HTML, JavaScript or something. Hopefully you're not using JavaScript for it because it's not very secure. Maybe you're using JDBC or something. You're using some technology. 100% of the time you have to use SQL because it's the only option you have. So IT people end up becoming really good at SQL, and then developers, they use it when they have to because they're not necessarily working at it from that particular perspective. They're not trying to get information out of anything. They're just trying to build a system. So believe it or not, like hardcore programmers have no idea what SQL is all about sometimes. They have very limited SQL backgrounds because they're working more with the technology. There's an example here of an SQL query, and it's written for business people. You have to select something from this particular table, and it's like talking. It's like, select last name, first name, address, and zip code from students. That's your query. It's not programming. So a lot of here's some more examples here. A lot of IT people shy away from it because they think it's like programming or writing in a scripting language or something, when it really isn't. It's business. It's actually kind of like COBOL in the old days. It's like writing. In fact, that's what COBOL was, a business language used. It was supposed to be a programming language for business people. This was back when everybody was programming, theoretically. Had Pascal, COBOL, all those little languages that were special purpose for different things. Because COBOL people are business people, so you wrote sentences practically as source code. And that's how you kind of, and then, essentially we ended up with programmers after that. So business people stopped programming. So programmers started programming. So now business people, forget COBOL, we don't have to worry about that anymore. So then COBOL's gone away anyway, but it had its time and it's had its place in history. I'm not going to go through these examples, but you can kind of see how you can kind of put together simple kind of expressions. The unrestricted use of the query language with a bunch of question marks next to it. This is one of the problems actually IT and IS people run into, is when they're given administrative rights to databases and then they run queries that cause major problems by leaving something out, by settings. And then what ends up happening is they end up destroying the data accidentally through user error. Not to scare you or anything, because what they should do is run something that doesn't, give you an access to it you don't have the capability of dropping a table, which is basically deleting it. You don't have the ability of updating. You can only query. So sometimes the control over the database is an important aspect of how it's being used and how protective the system is, which is why database management systems have really strong, almost like networking tools, almost like what a network admin would do. You can set groups, profiles, give access rights to certain areas of the database, to certain people for certain purposes. Because it's kind of like the old networking concept. You don't want to give admin or root access to everybody. Because you end up with problems in this particular query. The logic of it sets everything. That's it. Select first name, last name, pdiag, I don't know what that is, telephone number, from client where pdiag is equal to that. Yeah, it might be everybody. It might be only one. So the queries can actually, this is all pedophiles in Chester County receiving publicly funded mental health services since 1976. The easier systems are to use, the greater potential of abuse. Well, yeah, the easier the system is to use, the greater potential. In fact, the theory actually works with the amount of data that you save, which is the current thought is don't save it unless you need it. Because if you save it, there's a potential of somebody using it. Whether or not, whatever reason you saved it for, doesn't really matter a year from now. So you have all of this information that you've been saving. Lo and behold, someone's going to come by and use it for something. So it's don't save it, is essentially the current process. And then the application generation system, one of the other components of this database management system, allows you to build front ends, as they call it, applications. So contains facilities to help develop transaction-intense applications, maintained mainly by IT professionals. So the administrative system. And this is when you take an Oracle class, you learn all of the manipulation, the reporting, the administration part of it. The administration part of it is the backups, the recoveries. It's kind of like a network administration. Security management, as I mentioned before. Query optimization, reorganization, concurrency, change management. Managing the users of the system. In terms of backup and recovery, it's the same thing that you would do on a network. You'd provide some sort of a routine, weekly, daily, nightly, incremental, hopefully some sort of a way of recovering, restoring the system. That's actually important because if you're putting all of your data out there, you want to make sure that it's basically going to be recoverable if we have a fire, flood, or something like that. And then you can go take it to an extreme and say we have to store off-site backups. Which is kind of interesting because a lot of companies put a lot of work into backup systems. You walk into the network office, the IT office, and have tapes, to all these tapes, security tapes, network backup tapes, everything. And I just often wonder, what happens if there's a fire? What if there's a flood, a break-in or something? It's all gone. What happens if you just spill a little coffee on this pile of air? It's kind of fragile, think about it. The administration of security with a crude concept where access is for create, read, update, delete. So changing access rights. Query optimization, essentially, to minimize the response time. So you could actually do a lot of work with databases to make them more responsive, give them unlimited space. You don't want to make sure you don't run out of hard disk space for the database to run on. Reorganizing things, making them a little bit more accessible. It's kind of like how people rearrange their desk a little bit, clean out a drawer, throw away garbage, make things, stack things up in alphabetical order. You do the same thing with a database, actually. So, what you want to do is get an admin who's extremely detail-oriented and a little bit neurotic, who likes to go in and clean up temp files and clean up this and clean up that. Otherwise, you end up storing a lot of information you don't really need. The concept of concurrency control, being able to support many different connections simultaneously. Change management, being able to keep track of who made changes. Maybe it's in database logs, or maybe it's in some sort of some sort of a system. And I'm going to actually stop here because this is a good transition point. And so next week, I will be talking about data warehouses and data mining, and talk a little bit more about cloud computing. And I've got to actually go and put something together, and add it to the website. But I've actually had a lot of people request it. And if there's any other topic that you might want information on, feel free to send me an email message to thebehaker@itu.edu, and I can add it to the menu. And we can sit and you can listen to me talk about a topic of your choice in terms of strategic management of information technology. So, any questions for today? Nope. You guys all signed the roster? Yep. Then we are done and you are free to go.